Hey class, this video is our programming intro. We're going to be going over some basic scripts for adding character movement and some global variables into our Godot scenes. This video may be kind of long because we're going to be introducing a bunch of new programming concepts. Don't worry if they don't all make sense to you right away. These concepts are very abstract and they will take a little while before you'll really start to understand them, but we'll be reviewing the concepts and reiterating them throughout all of our programming lessons. So we're going to start by downloading our assets folder, and I'll go over where to put everything. And then we're going to create a couple new scripts and add them into a scene that I've created for you guys to work in. And then we'll add movement to the player. You can see I've got the full scripts down here for reference. So everything that we're going to write into our scene is right in there. I'll be going over all of these new programming concepts as we go through the scripts. So we have a lot to cover, so let's get started. So we're going to start by downloading the assets folder. These are some assets that I've prepared to use in different labs if you need them. They include scenes, sound files, animations, and other assets that might be needed by different scenes as you're working on them. Now we're going to create a new Godot project. You could also start by working on the project that you created, or you can create a new project for this specific lab. Let's save it in the MMP 270 folder. If you want to make it organized, you can make a developer folder for this lab. So now let's add some folders. We're going to need scenes, scripts, and sprites. Now let's go over to our Finder and get some assets and add them to our project. So you could dump all of the assets into your project, but what we want to do here is just find the assets that we need. So in the assets folder, there's some example scenes. The scenes that we need for this lab are the player scene, which we will add a script to. And then in the lab scenes, you can see there's a scene specifically for the programming intro. So let's grab that scene. We don't need any scripts. We're going to be writing those ourselves. We do need some images. So we need all these character animations. We can throw those in there. And then we need the tree for the scenery. And you could also throw all those images in there, but just to keep things simple, let's just throw in only the stuff that we need. So now we can see all of those things are imported into our project. Let's go ahead and change the filter setting on the sprites. For future reference, if we want to do that before we import our sprites, which would be smart, we can set the filter settings in our import settings. Let's go ahead and open up our programming intro. You might see some errors if you're missing certain scripts or things like that that are part of the assets. Just ignore those. I don't think any of those will be a problem. Here's our demo scene. You can see there's a little background setting of some trees. It looks a little bit offset because it's a parallax background, but we don't have to worry about that. This lab is not dealing with parallax backgrounds. We also have our player scene. If we play the scene, we can see that it's just our character in a little forest, but our player can't move. So we're going to add the player controller to fix that. Let's also set the window size. So I like to set the height to 512, so it's half of the width. Feel free to play around with different heights and widths there. You may notice some errors in the debugger. That is related to a signal that's attached to the default character scene. We can remove this signal from the animated sprite. Don't worry about what that actually does for now. We'll go over that in a later lesson. Let's go back to our scene, and now we can start working on our script. So to begin scripting, let's go over to the script window. This is where we can create new scripts and write our code. So we're going to create a new script and make sure to put it in the scripts folder. And let's just name it Global. I'm going to use a capital G here, and that just tells us that this is our global script. I'm going to set the template to empty, so it won't create any code for us. And we can see we just get a nice new script that says extends node. And if we right click and click lookup symbol on node, we can see the Godot API, which is nicely just built into the editor. And it tells us all the properties and methods that go along with this object. A node is our base object in Godot. So let's take a minute and talk about nodes and how they work. So let's talk about the Godot API. You may have heard this term before, but it may also be new to you. API stands for Application Programming Interface. This is a long way of saying it's a set of code of rules, properties, methods that we can use to tell Godot what we want it to do. So Godot is the application, we are the programmers, and the API is the interface between the application and us. So Godot is a game engine that does things like render sprites on the screen and detect if sprites are moving or if they're overlapping. That makes it easier for us to create a game. We still have to write some scripts because we have to tell Godot what we want it to do. And the interface tells us what kinds of things that we can write to make Godot do different things. Godot is structured in an object-oriented style, meaning that objects like nodes inherit properties from each other. There's a lot more to cover when it comes to these programming concepts, but for now, let's just talk about the basics, and we'll continue talking about them throughout the semester. So a node is an object, and it has some basic properties. It might have things like the position where you want it to be on screen. It might have a method to add or remove itself. And as we saw when we took a brief look at the API page, it has a ton of other methods and properties that are things that we as programmers might want to do with an object in our game. When we say something extends node, what we mean is that we want it to take all of the properties that the node has, but we also want to add some of our own properties. So for example, our character might have a speed, and we might want that speed to be 10. We could also extend the new character node that we created, which would then have all of the properties that the original node had, plus whatever we added. Instead of repeating our code, we can reuse the same code in different contexts. When we start a new script, the first thing we do is write some comments. In Godot, you can use a hashtag, and then anything you write after that will not actually be read as code. We can make some comments to make notes for ourselves or for other developers to explain what the script is for and how the code works. A good developer will always use a lot of comments to explain everything that's going on so that it's clear to other people who may read the code. So let's start with a comment that explains why this script exists. Global is used to track values through different scenes in the game. So let's explain what that means and then make our values. In Godot, we might have multiple scenes for multiple levels. And let's say in level 1, we have a score and we collect 3 coins in order to get a score of 3. When we move to level 2, unless we somehow transfer that score over to the new scene, we'll start back at 0. And we don't want to do that. So what we can do is use a global script to keep track of those values for us. And that global script can communicate with all of our scenes, and all of our scenes can communicate with the global script. And so this is just a simple way to make sure that we can keep track of the score and other things like the number of lives the player has over the course of many levels in our game. All right, so to save those values, we're going to create some variables, starting with the keyword var. So we have to pause again and explain what variables mean. And it may seem like we're moving pretty slow at this point, but since we're just first starting to talk about programming, there's a lot of basic concepts that we have to cover. And again, they may not make sense all at once, but we will review them throughout the semester, and eventually you will get the hang of them. So a variable is basically a way of storing information. If we think about our computer, it has a lot of memory, and we can imagine that memory on our hard drive as this big grid. And in that grid, we can store all sorts of different things like images and videos and simple things like numbers and decisions. And when we're writing code, we may need to come up with easy ways to remember where they are. So we can imagine a piece of memory on the computer might have some address, and that address may be a long string of random numbers and letters. And that's easy for the computer to remember, but it's very hard for us to remember that. So one of the things that Godot script does is it allows us to create names for variables, something like score or player lives. And we can assign values into these variables. So the score is a reference to this place in memory where we can say the score is 3, and then when we add 1, it becomes 4. The program will remember where this value in memory is for us. And so we don't have to do it. We just reference the score when we want to change it or update it or display it on the screen. Okay, so now that we know what a variable is, let's create some variables. So we'll start with the number of lives we want our player to start with. Call this total lives and set it equal to 3. So we have written our first line of code. Let's take a second and look at what we wrote. We start with a keyword, var, which stands for variable. This is a way of telling the computer that we are creating a variable. That's followed by a space, which separates the keyword from the name of the variable. The name of the variable is total_lives. After we name the variable, we add another space and then add an equal sign. The equal sign assigns a value to our variable. This is known as an operator. After the operator, we add another space and then the value, and that's the end of our line. In Godot, we don't end lines with semicolons like you may have seen in other languages. We just hit enter to go to the next line. We can, however, add comments at the end of lines, just like we can on their own lines. This is a nice way to organize your code because you can write code and a comment on one line. Next, we'll set the player lives, and we'll set that equal to 3 as well. This is what we're going to use to count the number of lives the player has left. So they'll start with 3, and if they get hit or something, they will lose a life. Our last value is the item count. This will start at 0, and we can count something like coins, or in the case of the demo, apples. And you could use a more specific name like apple count if you add more of these values, or if you have more things that you want to keep track of. But for now, we'll just use the generic item count. Let's talk a little bit about syntax. You might be wondering why I named the variables the way I did. If you have one word like count, you can just use that word. And typically in code, we'll start with a lowercase letter for a variable. But if we have 2 words like item count, in code, we're not allowed to use a space. The program will think that you're about to do something else, like you've already named the variable and you're about to move on to the equal sign. So we need to put something there, and typically we will put an underscore in Godot script. In other languages, you might use a capital letter, like item count with a capital C, but we can't use a space. So it depends on the language, and you can use whatever convention you prefer. Godot uses underscores in their API, so that's what I'll go with here. It's similar to how Python looks. Different languages will use different conventions. The last thing we have to do is add our global script to the AutoLoad. Because it's not part of a scene, we can't add it to a node in our scene. So we add it to the AutoLoad section and just give it a name. We'll call it global, which gets filled in automatically since that's the name of the script. And that way it will be accessible to any scene in our program. So as soon as we start playing the game or running a scene, the global script will become available. Now we have to add our input. So let's go back to project settings and go to the input map. If you're using the project that you made in the first lab, then you probably already have this set up. If not, let's just do it real quick. We're going to add move right. We're going to add move left, move up, move down, and jump. And we're going to use our same convention of underscores and lowercase letters for these names. And then we'll just add in the keys. So remember just to hit the plus, choose key, hit the key that you want, and then click OK. Don't hit enter because that will change the key. And let's set those up. Once you have those set up, you will notice that your player still does not move. So we need to now add our player controller script. To add the player controller script, we're going to choose the player and click new script. And again, make sure this is in your scripts folder. It's going to default to scene for some reason. And we want to call this player controller. Our object is named player. And so to avoid confusion, we want to name our script something else. And player controller makes sense because it's the script that moves the player. The player is a kinematic body 2D. This is a physics body. It basically means that it can move around. If we take a look at the documentation, you can see there's a bunch of different stuff that will help us make the player move in the scene. Things like, is the player on the floor, and move and slide. There are also some tutorials linked there if you want to look deeper into how kinematic body 2Ds work. But essentially, it's something that we need to make our player work with the Godot physics engine and move around. So the first thing that we're going to do is add a variable that can be set by the editor. This line looks very similar to our previous variables. We just say var speed equals 100, but we add another keyword in front called export. And what that does is it makes the variable and the value appear in the editor window. This is really convenient because in our script, we can specify values that we want to change without having to update the code. So for example, if you're working with a designer and they want to make the character go faster, they can change that value in the editor window without ever looking at the code. In this case, we want to use variable names that explain well what the values do so that our designers will know what's going to happen when they make those changes. Next, we're going to add a couple of what we call private variables. These are variables that only the script knows about. The first one is just is_alive. This just keeps track of whether the player is still alive or not so that we can stop moving the player if they die. Notice that it doesn't show up in our script variables because it's not an exported value. This value is a Boolean. This is a type of data. Let's briefly talk about the data types that we'll see in this lesson. So far, we've seen a lot of numbers. Numbers are what they sound like. They're numerical values like 0, 1, -1, or 100, which can be added or subtracted. And they're very useful for doing things like moving our character or determining our character's position. Booleans are simple values that are either true or false. They can only be true or false. They're good for making decisions or keeping track of a status, like whether the player is alive or not. The other type of data that we'll use are strings. Strings are sequences of characters. They could be used to save the name of a level or some dialogue that a player might say. Our next value is velocity. This is how fast the player is moving and also the direction that the player moves. For this, we use a vector2. This is a new data type. Notice that when we create a vector2, it looks a little bit different from our other values, like our speed. A vector2 is an object with lots of different properties and methods, sort of like our kinematic body. So we just use the vector2 name with parentheses afterwards. The parentheses tell Godot to create a new object that has the properties built in, like x and y for the velocity. So we're already introducing new data types and we're already breaking away to another explanation, but we're learning a lot of stuff right now, so that's okay. A vector2 is basically just two numbers stored in one variable, but it's very convenient for doing different types of math because we can think of that as a direction. And so we can think about how far a player has to move on the x-axis and the y-axis. And we can save both of those numbers. And then we can do complicated math using that direction later on to calculate things like how fast is the player moving? Are they running into stuff? Should they be sliding? We can also use it to set the animations, which we'll do a little bit later. And so it's basically just two values, the x and the y values stored in one place. Here we see our character starting at 0, 0. And if we want to move right 2 and up 1 in one frame, we can do that by setting the velocity to a vector2 with 2 for the x and 1 for the y. Having it in this format means that we can multiply it by other vectors or separate out the x and y values to use in other operations. Our next line of code is func_physicsProcess with delta between the quotation marks and the semicolon at the end. So we're definitely gonna have to pause here. Hopefully this is the last time because there's a bunch of stuff in here that we are going to need to explain. So the first thing is the word func, and that just stands for function. We'll talk about what that means in a second. The next thing is physics process, and that's part of the Godot engine. That's the name of this function, and it's a built-in function. We know that because it has an underscore in front of it, and it's one of the functions that Godot creates for us to use in our game. In the parentheses, we see the word delta. That is something that Godot calculates for us. That's the time in between frames. The colon at the end represents the beginning of our function scope, which is the code that goes inside of our function. On the next line, Godot has conveniently indented us automatically over by 1. And whenever we start a new function, we indent all of the code inside of that function so that we know visually and Godot knows through syntax where the function starts and ends. This is another convention of the Godot script language that is similar to something like Python and other languages which use indentations to represent code scope. So let's talk a little bit about what's going on in there, and we'll start with the Godot engine. So our Godot engine is rendering our graphics 60 frames per second, or at least it's trying to. As it's doing that, it's calling different functions that have different purposes. And it names its internal functions with an underscore at the beginning so that we can write our own version of the functions without overwriting Godot's functions. So for example, underscore ready is a Godot function that will run once when we start our scene. And so we can set some basic values at the beginning of the scene. We will see examples of this in scripts that we write later on in the semester. The function that we just wrote was physics process. And this is a function that runs every frame after Godot calculates the physics. And so this is useful because we know that Godot has already looked at things, whether they have run into each other, what should be sliding or bouncing. And Godot will also tell us how long it took from the last frame. And we can use that time to change the way that we code our player or other objects in our scene. For example, if we want our player to move a little bit each frame, we may want to change that amount based on the amount of time that the frame took so that we get smooth movement that isn't affected by the frame rate changing. Now let's talk about functions. So in Godot, the shorthand FUNC stands for function. A function is basically like a recipe or a series of commands or instructions that can be run multiple times. An example I always like to use is a recipe for a peanut butter and jelly sandwich. It pretty much stays the same every time you do it. You might add different things like a different flavor of jelly or a different type of peanut butter, but the steps are still the same. You get your bread, you put on the peanut butter, you add the jelly, you put the bread together, and maybe you slice it in half, and you have a peanut butter and jelly sandwich. Functions in Godot work the same way, except they do things that we want our game to do. So for example, inside of our physics process, we are going to ask a question. Is the player hitting a button, like the left key or the jump key? If they are hitting that button, then we want to change what's happening in our program. We want to make the player move or jump or do other actions that the player is doing with their input. And because it's a video game, we need to be able to do this over and over again, testing for different conditions that may be changing as the player plays. So now let's write the player movement. The first thing we want to know is if the player is alive. This is called a conditional statement. We say if is alive, colon, and that adds a new code scope. So we indent again. We're going to actually put in a whole new function here called player update. So every time you see a colon, that means the next line is going to be indented. And we can have code scopes opened in functions as many times as we need to. So we're going to call this player update function. If the player is not alive, we're just not even going to bother with this. We have to pass the delta to the player update. This is known as an argument. So we get this from Godot and we're going to pass it into our own function just so we still have it. Otherwise, that delta would disappear once the physics process is over. We can see our player update line is its own code scope. Godot knows that because we've gone back to the original indentation. So I put pass there for a second because I didn't want to see an error. So let's get rid of that. And then let's write a comment to say what's happening with our player movement. We're going to start by assuming that the player isn't actually hitting any buttons. So that way, if the player was hitting a button in the last frame, it won't carry over to this frame. So the way to do that is set our X and Y velocity to 0. So we'll assume that those values are 0 until we do some other calculations. Next, we're going to have to ask some more questions. So we need some more if statements or conditional statements. So we'll start with if, and then we'll use our input. The input is a part of the Godot engine that will include key presses or mouse button presses or any other events or input that the player can do. Notice that if I put a dot after a piece of Godot code, it will often show me some options for what to add there. And so I can just click on the function that I want to use, and then it'll also show me all of the input that's available. So I can just click on those inputs as well. It's fine to type them out, but it's a little less error prone and a little more convenient just to click on those hints that Godot gives us. So we're going to check to see if the player is hitting the right button. And if so, we're just going to add our speed value to the X property of our velocity. Notice that even after I added that move right, nothing happens. And we've changed the velocity, but we haven't actually applied it to the player. So to apply it to the player, we want to use the move and slide function. This is going to take the velocity and then apply physics to it. And it's going to move our player, and it'll make it slide a little bit at the end of its movement. So now we can see our player moving to the right, but it can't move in other directions. Notice there are two arguments for move and slide. The first is our velocity that we've calculated, and the next one is vector2.up. This is basically just saying that in this world, up is up. So we have to add in the rest of our actions, and we're going to continue to use if statements and our input from Godot to decide where to move. There's a shorthand to write this. So instead of saying velocity.x equals velocity.x plus speed, I can say velocity.x plus equals speed. This means the same thing. Because this is a very common thing to do in coding, there is a shorthand to do it. So let's add another input.isActionPressed, this time for move left. And isActionPressed basically just means is the player hitting the action key or button for a gamepad. So if we're going to move left, now we have to move the x value in the negative direction. So instead of using plus equals, we'll use minus equals. And so we're just taking the speed value, which is set by the editor and is default to 100. And we're subtracting it from our default velocity, which starts at 0. And so that will move us to the left. And now we can move right and left. So that's pretty exciting. We're starting to get somewhere. So now let's add our vertical movement. If input is action pressed, and let's do move up. And now we're going to do the same thing, except on the Y. In Godot, up is negative and down is positive. Y gets larger as we move down the canvas. So when we click move up, we're actually going to be subtracting speed from Y. Whereas when we hit move down, we'll be adding speed to Y. So now we should have movement in 4 directions, which is pretty exciting. There we go. We can move around. So now we've got our movement working, and we need to add our animations. So we need to set the animation state of the player based on the player's movement. Let's go ahead and take a look at the player scene that's included in the assets. You can see there's a few different animations. The only ones we really need right now are the walk and the idle animation. The idle animation is just when the player is sitting around. For this one, it's very simple. The character just blinks their eyes. The walk animation shows the character walking. It's also very simple, just 2 frames. This might be a good opportunity to use your own character animations or to use another student's character animations for this project. So here's where we get to use our fancy vector2 math. First, we're going to assign the velocity, the result of our move and slide function, back to the velocity. This might seem a little confusing, but move and slide is actually going to change the velocity a little bit depending on the physics of the game engine. And so we want to get that back. So we're going to assign that back to our velocity value. Next, we're going to check something called the length squared of our velocity. This is a really convenient function that a vector2 has built into it, which essentially tells us if we're moving in any direction. So instead of having to ask, are we moving right or left or up or down? We can essentially say, are we moving at all? Is the distance or length of our vector at least bigger than 1? If that's the case, then we want to change our animation to the walk animation. And that's very easy to do. We can reference the animated sprite in our scene by using the $sign operator. In Godot, the little $sign basically allows us to get a reference to anything that's inside of the scene that our script is attached to. So that's an easy way to get our animated sprite. Our animated sprite is a Godot object that has different methods, and we can just use play. So we can say animated sprite.play, and then the name of the animation we want to play. So that just has to match the animations that we looked at earlier in the player scene. So if our velocity length or length squared is greater than 1, that means we're moving in some direction somewhere. And so that means that we want to change to walk. Else, and here's the first time we've seen an else statement. Else basically means if the first statement is not true, then we move on to the next statement. So if the velocity of the player is not greater than 1, then the player is standing still, So we want to play the idle animation. Finally, to give our player a little bit more directionality, we can change the direction of the sprite by flipping the horizontal value of the sprite. You can see one of the properties of an animated sprite is flip H, which stands for flip horizontal, and that flips the direction that the sprite is facing. There's also flip V for flip vertical. And this is a simple test just to see if we're moving in to the right or to the left. So we can say if velocity.x is greater than 1. So that basically means that we're not standing still and we are moving to the right. In that case, we won't flip our character because the character is already facing to the right. So we don't need to do anything. If we move to the left, if our velocity is less than -1, that means we do need to flip our character to have the character facing in the direction that they're moving. You could also create a new animation. So you could have a walk right and walk left animation and just swap those animations based on the same logic. Notice that I separated these into two if statements. That's because I do want the player to stay facing in one direction, even if they're not moving. So if I said else instead of if for the second statement, then the player would always default to facing left, even if we had just moved to the right. But by using two if statements, we create this kind of zone in the middle that it just ignores. So if the velocity is 0, the player just stays facing whichever direction it was last facing. This is a pretty simple way to make sure that our animations are facing the direction that the player is moving or just moved. So that just about wraps up our player controller. This is basically all you would need for an RPG style game. We will be adding some physics in the next lesson so that our player can jump. And there's a bunch of new code that we have to add in for that. So we'll be building on this lesson. So I know that was a lot of material to cover in one lesson, and it was probably a little bit confusing if you haven't written any code before, or if you've never written Godot scripts before. So don't worry about that. As long as your script works, you should be happy. And we will talk more and more about these concepts throughout the semester. So by the end of the semester, you should have a good handle on all of them. So we're done with the lab. The last thing we need to do is just upload our results. So let's go to the Open Lab and start a new post. We'll choose the Programming Intro category and write a little title. And then just come up with a description. If there's something interesting or cool that you learned in this lab, please feel free to add that here. Just reflect on this process and what you learned, and then include a screenshot of the result. So if that has some new art, that would be very cool. But if you're just doing this intro lesson and using the default assets, that's fine as well. So once you're finished writing your little description, just put in a screenshot and we can preview, make sure it looks good, and then click publish, and you should be done with this lab.